Okay, here we go. We're picking back up in Chapter 7 of Polynomials. Today, what we're going to focus in on is GCF factoring. So this is basically reverse distributive property. So we are going to look for the greatest common factor of all the numbers, all the variables, and we are going to divide it out of everything. All right, so GCF factoring is just simply factoring out the greatest common factor to all of the polynomials. It has to go into everything there. Basically, like I said, this is reverse distributive property. So what we're going to do, the steps involved is step number 1, we're going to look at the coefficients and constants. What's the greatest number that goes into them? Write this on the outside. Now, one little rule with that, the leading coefficient cannot be negative. So if it is, you must factor out a negative with your number. Okay, so you've got to make sure you do that. Now, what that will do is when we factor out that negative, it flips the sign of everything left inside. Step number 2, we look at the variables and determine what is the greatest number of them shared. We write this on the outside right along with the number. Step number 3, we divide each term by what you wrote on the outside, and we write what's left of the polynomial inside the groupings. And then your final answer should look like this, where we have a GCF on the outside and then whatever is left on the inside. All right, so here we go. The first thing we're going to do is we're going to look at our numbers. I have 24 and 16, and I ask myself, what number goes into both of those? So if you struggle with that at all, what you can do is you could even write like your factor chart over here on the side. You could say 1 and 24, 2 and 12, 3 and 8, 4 and 6. So all those numbers go into 24. We could also do that for 16. 1 and 16, 2 and 8, and 4 and 4. Now, if you notice, the biggest one they have in common is an 8. So we're going to take the 8 and write it out front. Now we look at our variables. I have an x here, but I don't have any variable there. So therefore, they don't share any variables. So now I simply take my GCF and I divide it into both of these. So 24x divided by 8 is 3x. 16 divided by 8 is a positive 2. And that is how we do GCF factoring. Okay, let's take a look at number 2. So on number 2, the first thing I look at is I say, okay, what numbers go into 9 and 27? Well, if you think about it, 9 has 1 and 9 and simply 3. 27 has 1, 27, 3, and 9. So what is the largest one they share? It would be a 9. So the thing I'm taking out is I'm taking out a 9 from both of them. I look at my variables next. This one has an x, this one doesn't have any, but I do notice that my leading coefficient is negative, so I'm going to simply take out a negative 9. So now I take that and divide them by negative 9. So negative 9x divided by negative 9 is simply x. 27 divided by a negative 9 is a negative 3. And that is my factored form. Okay? Now let's take a look at number 3 here. So we have x to the 4th minus x to the 3rd. So remember x to the 4th, what that means is we have x times x times x times x. X to the 3rd means x times x times x. So here's what we're looking for. How many do they have in common? How many do they share? Well, the answer would be 3 x's. So my GCF is going to be x to the 3rd. So now remember when we divide, we're subtracting. So if I have 4 x's in the top, I have 3 in the bottom, I'm going to have 1 left and it will be in the top. Over here, I have 3 in the top, 3 in the bottom, so they all go away, leaving me with just the 1. So that one would simplify to x to the 3rd times the quantity x minus 1. Okay, now let's take a look at number 4. So if I look at number 4, I have three different values going on. I have y to the fifth, which means y times y times y times y times y. And then y to the third, y times y times y, and y squared, y times y. So how many do they have in common? And the answer would be 2 y's. So what we're going to do is we're going to take out y squared. So now I'm going to divide each of these by y squared. So if I have 5 y's and I take away 2, I'm left with y to the third. If I have 3 y's and I take away 2, I'm left with 1 y. And if I have 2 y's and I take away 2 y's, I'm left with just a 1. And that is our GCF factoring with just the variables. Okay, so now what we're going to do is we're going to put it all together now. So we start off, remember I said start off looking at the numbers first. So in this problem we have a 15, we have a 30, and we have a 25. So the largest number that goes into both of those is going to be 5. Next, I have an x to the fourth, an x squared, and an x. So how many do they have in common? And they all have one x in there. So now what I'm going to do is I'm going to take each one of these and I'm going to divide it by 5x. So 15 divided by 5 is 3. X to the fourth, take away 1, you're left with x to the third. Negative 30 divided by 5 is a negative 6. X squared, take away 1, you're left with an x. 25 divided by 5 is 5. You had an x, you took it away. So that would be my GCF factoring. Okay, let's take a look at number 6. So on number 6, I start off and I say, okay, I have 21, 14, and 35. So what goes into both of those, all three of those, is a 7. Okay, now we look, we notice that the front is also a negative, so I'm going to take away a negative 7. Then I look at my x's. I have 5, 4, and 3. So the most they have in common is 3. So we're going to take each one of these and divide it by negative 7 x to the third. Negative 7 x to the third. Okay, so now when we divide, negative 21 divided by a negative 7 is a positive 3. I had 5 x's, I took 3 of them, so I'm left with 3x squared. On the second one, I have a positive 14 divided by a negative 7, that's a negative 2. I have 4 x's, I take away 3, I'm left with 1x. The last one, I have a negative 35 divided by a negative 7, that's a positive 5. I have 3 x's, I take away all 3, and that would be my factored form. Okay, let's take a look at number 7. So we start off, what goes into 36, 24, and 48? Now, I want to show you something that can happen here. So if I look at those, I know that 6 goes in. So I'm going to take out a 6. Well, now I look at my x's. I have x to the fourth, x to the third, x squared. So the most x's would be x squared. So now I'm going to divide each of those by 6x squared. So when we do this, 36 divided by 6 is 6. X to the fourth divided by x squared, that gives me x squared. Negative 24 divided by 6 is a negative 4. I had 3 x's, I took 2, so I'm left with 1x. Negative 48 divided by 6 is a negative 8. I had 2 and I took 2. Now, I want you to take a look at what's left inside. Does 6, 4, and 8 have anything in common? And the answer, hopefully you notice, is yes. They all can be divided by 2. So what I can do is I need to take this further. What that means is I took out a common factor, just not the greatest common factor. So what we do is we take the 2 and we times the 6, and that's going to give me a 12. So my greatest common factor should have been 12x squared. Now I divide it, and I would be left with 6 divided by 2 is 3x squared. Negative 4 divided by 2 is negative 2x, and negative 8 divided by 2 is negative 4. Now, if you look inside your grouping this time, is there anything common to all three? And the answer would be no. And that is how we do GCF factoring.